Hi, good evening. My name is Dhanupriya, working at SNS College of Pharmacy. My DT topic is on 3D printing. 3D printing is also known as additive manufacturing. It is the construction of a three-dimensional objects from a CAD model or a digital 3D model. It can be done in a variety of processes in which a material is deposited, joined, or solidified under computer control, with material being added together, such as plastic, liquids, or powder grain, being fused, typically layer by layer. In the 1980s, 3D printing techniques were considered suitable only for the production of functions or the aesthetic prototypes, and a more appropriate term for it at the time was rapid prototyping. As of 2019, the precision, repeatability, and material range of 3D printing have increased to the point that some 3D printing processes are considered viable as an individual industrial production technology, whereby the term additive manufacturing can be used synonymously with the 3D printing. Modeling 3D printing models may be created with a computer aided design, that is a CAD package, via the 3D scanner or by a blind digital camera and a photogrammetry software. 3D printing models created with CAD results in relatively fewer errors than other methods. Errors in 3D printable models can be identified and corrected before printing. Detail of the Stuhlberg in Amsterdam, the world's first 3D printed metal bridge. Traditionally, 3D printing focused on polymers for printing due to the ease of manufacturing and handling polymetallic materials. However, the method has rapidly evolved, not only print various polymers but also metals and ceramics, making 3D printing a versatile option for manufacturing. Layer by layer fabrication of three-dimensional physical model is a modern concept that stems from the ever-growing CAD industry, more specifically the solid modeling side of a CAD. Before solid modeling was introduced in the late 1980s, three-dimensional models were created with the wireframes and surfaces. There are many software available. One is a 3D software. There are many different software tools available, from industrial grade to open source. We have created an overview on our 3D software package. We often recommend a beginner to start with Tinkercad. Tinkercad is free and works in your browser. You don't have to install it on your computer. Tinkercad offers beginner lessons and has a built future expert your model as a printable. Example STL or OBJ. Applications of 3D printing. It has been used in manufacturing, medical, industry, and socio-cultural sectors to create successful commercial technology. More recently, 3D printing has also been used in the humanities and development sector to produce a range of medical items, prosthetics, parts, and repair. The earliest application of additive manufacturing was on the tool room end of the manufacturing spectrum. For example, rapid prototyping was one of the earliest additive variants, and its mission was to reduce the lead and cost of developing. Second one is the food industry. Additive manufacturing of food is being developed by squeezing out food layer by layer in three-dimensional objects. NASA is looking into the technology in order to create 3D print of food to limit the food waste and to make that is designed to fit an astronaut's dietary needs. Third one is the health sector. 3D printing has also been employed by researchers in the pharmaceutical field. During the last few years, there has been surge in academic interest regarding drug delivery with the aid of AM techniques. This technology offers a unique way for materials to be utilized in novel formulation. AM manufacturing allows for the usage of materials and compounds in the development of formulations in ways that are not possible with conventional traditional technique in the pharmaceutical field. That is example tableting, cast molding. Last one is the educational sector. 3D printing and open source 3D printer in a particular are the latest technology making inroads into the classroom. Some authors have claimed that 3D printers offers an unprecedented revolution in STEM education. The evidence for such claims comes from both the low-cost ability for rapid prototyping in the classroom by students, but also the fabrication of low-cost, high-quality scientific equipment from open hardware design forming. Future application for 3D printing might include creating open source scientific equipment. Thank you.